All right, you don't need to see my mug in the corner anymore, so let's go ahead and let's play from current slide. All right, so here we go. We're talking fluids and materials that flow. Basically, fluids is any material that flows. And so you could even argue, sometimes we've had some heated geek debates here in the physics department about, well, is glass a fluid? Because if you go to ancient Europe or places where they have old cathedrals that are 1,000 years old, but they have glass in them, or 600, 400 years old and they have glass. They're thicker at the bottom because the glass is like oozed down to the bottom, and so that means they're flowing. So is glass a liquid or a solid? And it's, of course, if you see glass blowers, it's very viscous and has a viscosity when they're making it, but then it hardens into a solid because it shears. And it's kind of what ends that debate every time. We're going to be looking at air mostly because that's what makes a boomerang work, is air. All right, and air works a lot like a fluid. All right, so tennis balls get much of their bounciness because they're under pressure. They're under 2 atmospheres of pressure. We know the same is true for basketballs. Pressurization is determined by their coefficient of restitution, which you all did a lab on that, as well as other balls, okay? And so the pressure on Earth, this is one of your questions in your pre-lab, is we talk about pressure, but what does it do to? What is the pressure here on Earth due to? Pressure of air. If an object's in a fluid, here's our little man. If he's in a fluid, the fluid above will exert a weight on him that is equal to rho, which is his density, the density of that fluid that's on top of that person, times our good old 9.8 meters per second squared, times however tall this air is. Like when you go under, and we'll talk about going underwater in a swimming pool, right? And if an object is in a fluid, the fluid above will exert pressure, and the atmospheres is about 10 kilometers high and has a density of 1.2 kilograms per meters cubed. Notice this is a density, mass per volume. Mass per volume. Then, ballpark, this is close to the accepted value of atmospheric pressure. So one of my questions is, how many pounds per square? So look at your thumbnail. This is what I always tell all my students. Look at your thumbnail and then tell me how many pounds of pressure are from the air, how many pounds of pressure are smashing down on your thumbnail right now? I think one more click and we got it. It's a metric. In the English system, we use about 14.7 pounds per square inch, about 15 pounds. So when you go to this, when you check the air pressure in your tires and it says 32 psi, it's actually more like 47 psi because there's also the gauge pressure subtracts, the gauge automatically subtracts out that 14.7 pounds per square inch here on Earth. Okay, that's enough for the introduction. This is end of track 1. Whoops, sorry, takes me a minute to find it.